2. Okay, skills 7. We are off and running. It says, evaluate f of 2 using synthetic substitution. So basically and we're given a function. Basically what it is we're going to substitute 2 in for every x in the given function. All right, let's do it. We got this. So we have 2 times 2 to the 4th. And I don't like how that marker looks. So you know what? I'm switching it up. Okay, so 2 times 2 to the 4th plus 2 to the 3rd minus 3 times 2 squared minus 5. Yes, we have a calculator, but just so we have some practice with our order of operations, exponents first. 2 times 16 plus 2 cubed is 8 minus 3 times 4 minus 5. All right, keep going with me. We get 32 plus 8 minus 12 minus 5. 32 plus 8 is 40 minus 12 minus 5. Then we get 28 minus 5 is 23. So f of 2 is 23. Okay, so that means when x is 2, y is 23. But what does that mean to us with a function and a factor? Well, let's take f of x and let's divide it by x minus 2. Okay, we know that we have long division. We know that we have, synthetic. Most of us like synthetic. But I'm going to go ahead and for b, sorry, I'm going to use long division. And I'm going to do it over here in blue so that we can see. So x minus 2 is going to divide into 2x to the 4th plus x cubed minus 3x squared minus 5. We don't need any placeholders because it goes, we do, because we're missing that linear factor. Whew, good thing we caught that, right? 0x and then minus 5. You always, always, always have to ask yourself if you need a placeholder. Okay, off we go. 2x to the 4th divided by x leaves us with 2x cubed. When we multiply it back through, we get 2x to the 3rd minus 4x to the 3rd. This should definitely be 2x to the 4th. There we go. And then we subtract or change the signs. So then that first term cancels out. We end up with 5x to the 3rd. Bring down the negative 3x squared and start over. So 5x to the 3rd divided by x gives us a positive 5x squared. Multiply the 5x squared to the binomial. We get 5x to the 3rd minus 10x squared. Subtract or change the signs. So then we end up with 7x squared. Bring down the placeholder. 7x squared divided by x gives us a positive 7x. Multiply it through. 7x times x is 7x squared. 7x times negative 2 is a negative 14x. All right, what do we do next? Subtract or change the signs. So our first term cancels out again. We end up with 14x. Bring down the negative 5. 14x divided by x gives us a positive 14. Are we having fun yet? And then we multiply. So 14 times x gives us 14x. 14 times negative 2 gives us negative 28. All right, grand finale. Subtract or change the signs. So we're left with a remainder. Ew, I do not want that in orange. We're left with a remainder of 23. Okay, so we divided. So when we've divided our given function by the factor or the linear factor, let's say that's more appropriate, of x minus 2, we get 2x cubed plus 5x squared plus 7x plus 14. And then we have that remainder of positive 23. So we'll put it over what the divisor was. So yes, the remainder is 23. Wait a minute. What do you see? Do you see what I see? It's like a Christmas song. Do you see what I see? Oh, shoot. Get back here. Sorry, guys. Okay. That's what I get for my little side note, right? think it has stopped glitching. We shall see. But yeah, when we substituted 2 into the given function, the output was 23. What's the remainder? 23. This is called synthetic substitution. You can substitute in a possible value that is generated from a linear factor to see if a remainder exists. Since the remainder did exist, it is not a factor. X minus 2 is not a factor of f of x. Is 2 a 0? No, because x minus 2 does not divide evenly. Is 2 a solution? No. When we substituted 2 in for x, we did not get a corresponding output of 0. We did not get an x-intercept. We did not get a solution. We did not get a root. We did not get a 0. Okay, all of those items and facts are interwoven, and it's pretty awesome. Okay, so example 13. Now we can use a synthetic division. is asking us to synthetically divide the given function by x plus 2. All right, let's do it. So I'll do it in blue again. Since x plus 2 is our linear factor, when we were to solve it, we would find -2, and that's what goes in the box. Go ahead and write the coefficients of each of the terms in the function, making sure we don't need a placeholder, and we don't because it has cubic, quadratic, linear, constant. And we're going to add for synthetic division. Drop down the first coefficient, multiply by the divisor in the box, we get -2, we add, we get -3. Multiply by -2, we get 6, add, we get -4. Multiply by -2, we get an 8, which leaves no remainder. So when we divided, we ended up with x squared minus 3x minus 4. Because remember, we're dividing. We're taking a piece away, hopefully evenly, and thus leaving us with one less exponent, one less degree. So if we were to substitute f of -2 into the function, we should get 0 as a remainder. As our value. Let's see. We get -2 cubed minus -2 squared minus 10 times -2 minus 8. Okay, well, a -2 cubed comes up with -8 minus -2 squared is 4 plus 20 minus 8. Okay, then we get -8 minus 4 is -12 plus 20 minus 8. Do you see it? And then we get 8 minus 8, which is 0. Yes, so we did get a y, an output of 0. So is -2 a solution? We say emphatically, yes it is. Is x plus 2 a factor? Yes, because the solution of -2 came from the linear factor of x plus 2. So they correlate. F of x divided by x plus 2 gives us x squared minus 3x minus 4. And then it says to write it completely in factored form. Well, this one always trips up students because we forget that x plus 2 is a factor. You have to include that. Please, please, please do not forget to include the given factor if it divides evenly. In fact, write that down. When asked to write something, some function in complete factored form, do not forget the given factor that you just divided out evenly. So important. Okay, now, what's left over? Can it factor? Well, yeah, what two numbers multiply to -4 and add to -3? I'm going to say x minus 4 and x plus 1, ladies and gentlemen. There is that cubic incomplete factored form. So what are the other zeros? Well, x would equal 4 and -1. How do we know? We took both of these binomials and set them equal to 0 to solve. All right, let's try to make a sketch, yes, of this using the zeros. Okay. So we know that we know that we're going to have a 0 at -2, at -1, and at 4. 1, 2, 3, 4. Okay. Going back to the given, it's a cubic, so we have opposite end behavior. We see that it is an odd degreed function with a leading coefficient that is positive. So the end behavior goes down and up. And I'm going to have to cut through all of my zeros. So starting from the left, I go through the first one, go through the second one, go through the third one. Boom, there is my sketch. Now, it doesn't matter if your relative max and mins are as low or as deep or as high as mine. That doesn't matter. What matters is that your end behavior is down to up and that your zeros are graphed appropriately. Nice, good job, guys. And our last example. Oh, yes, word problem, application. Okay, the polynomial bleh, expresses the volume. Okay, that's key, volume in cubic inches, that's important too, of a box. And the length is x plus 5 inches. What are the other two dimensions of the box? Okay, so we already know that the length is x plus 5 inches. If they tell us that that exists, that means it's going to divide out of the polynomial evenly. Okay, so we could use long division, or we could use synthetic to see what's left over. All right, we'll use synthetic. So the linear factor of x plus 5 generates a solution that would be negative 5. So that's what we're dividing by. I'm going to use the coefficients of 1, 9, 23, and 15 to synthetically divide and see what polynomial is left over. Okay, we're adding. I'm going to drop down the first coefficient, multiply by our solution, we get negative 5. Add, you get a positive 4. Again, multiply by negative 5, you get negative 20. Add, you get a positive 3. If we multiply by the negative 5, you get negative 15. Add, we get a remainder of 0, which we knew would happen because we were told the length exists at x plus 5 inches. Okay, so then that means this is x squared plus 4x plus 3. We always start 1 degree less because we're dividing. We're taking away one of our x's. One of our degrees. And then we need to factor this because it asked for what are the other two dimensions of the box. So if we factor, we get x plus 3 and x plus 1. It doesn't matter which one is the width or which one is the height. All that matters is that the other two dimensions, we're going to say are x plus 3 inches. Super important that you add the unit of measure and x plus 1 inches. And that's our final answer. Please, please, please do not forget the units of measure. That is a very common mistake. All right.